everyone. What an honor it is to be up here amongst this amazing speaker lineup. So Shopify is also a sponsor to this conference, so I'm going to just for one hot sec take off my speaker hat and put on my sponsor hat to tell you about Shopify. So we're the leading cloud-based multi-channel commerce platform, and we are hiring. So if any of what you hear about today is interesting to you, please check out our careers page or come and find me afterwards. I joined Shopify over 6 years ago now, and at the time we had less than 200 employees, and we're serving around 70,000 merchants with a relatively straightforward online store and point-of-sale offering. Now fast forward to today, and we have over 4,000 employees, are serving upwards of 800,000 merchants all over the world, including some as big as Kylie Jenner, and our product offering is a lot more complex. So we learned a lot about how to build software along the way, and I want to share some of those learnings with you today. We're all here in this conference to grow our technical leadership skills. As everyone in this room knows, being a good technical leader encompasses a lot. It includes many aspects of people management, like having good one-on-ones and helping identify your career ladder. But it also includes some more technical aspects, like having an opinion on how your team architects and builds the software, and being able to course correct if the current solution is no longer best serving the product or the team. These technical decisions can in turn affect your team's productivity and happiness, so getting it right can result in a virtuous cycle. At some point in the not-so-distant past, Shopify was a massive monolith. It was responsible for billing merchants, customer checkout, managing developers' apps, creating orders, handling shipping, updating products, and a lot more. And all of this was being powered by the same Shopify core codebase. So Shopify is built using Ruby on Rails, and it started similarly to how all Rails projects starts, with a command to rails.new. Our CEO, Toby, was actually also our first engineer, and he started writing Shopify with a zipped version of Rails that was emailed to him by DHH right after creating it. But since then, it has evolved into one of the largest Ruby on Rails codebases in existence. So the architectural ideas in this talk can be applied to a lot of different programming languages, but I am going to be giving some concrete examples to help drive the points home, and they're going to be given within the context of Ruby on Rails applications. For those of you not familiar with Ruby on Rails, all of the code is globally accessible, meaning that you can call anything from anywhere without having to worry about explicitly saying that you depend on it to get access to it. What this meant for us at Shopify is that, as an example, the code that was used to calculate shipping rates could use parts of the code that was used to calculate tax rates, and vice versa, even though they were powering different parts of the product and arguably should not be sharing code. There are a lot of benefits to monoliths. They've been getting an especially bad rap in the tech scene recently, so I do want to emphasize that while it's no longer the best solution for us at Shopify, it was for a very long time. Even though this talk is called Deconstructing the Monolith, I would actually still recommend that new companies and new products start off with a monolith or with a minimal design. Let me explain why. In the beginning, the number one priority is getting your product to market, and it's not worth spending too much time trying to get your design to be perfect. Even if you did spend time up front, there's no way that you would actually get it right because you don't have all the information yet about your product and your problem domain. So start with no design and move as fast as you can to add the required functionality. However, a time will come where it becomes slower and slower to add the same amount of incremental functionality. Martin Fowler refers to reaching this point as crossing the design payoff line. So where all the three of the lines meet on the graph behind me denotes the perfect time to design. But unfortunately, no one's going to come and knock on your door and be like, hey, you're at your design payoff line. And also, unfortunately, attempting to design or re-architect too soon or too late both have associated downsides. So there is really no magical way to figure this out, unfortunately. I would love to be able to tell you that. But what I will do is share some of the symptoms that we experienced that told us that we had passed our design payoff line in hopes that they might help you identify when you hit yours. We realized that we had to re-architect in early 2016 when the cons of our monolithic system began to outweigh the pros. Specifically, there were a couple things that served as tripwires for us. The tests were so slow to run that a lot of people just fully opted out of running them locally. They were also extremely painful to write due to how entangled all of our objects were. Making a seemingly innocuous change could trigger a cascade of unrelated test failures. And that's because, in the example I gave earlier, if the calculation of tax rates is using shipping code, then if we change how we update the shipping, it could break the test for the taxes, and it wouldn't be super clear why. And one of the main cons was that developing in Shopify required a lot of context to make seemingly simple changes. It was taking new developers way too long to onboard onto teams because they not only had to understand the code owned by their team, but also the code owned by many other teams to be able to make seemingly simple changes. So all of these challenges were affecting our developer productivity and happiness. We realized that all of the things we liked about our monolith were a result of the code living in one place. And all of the issues we were experiencing were a direct result of lack of boundaries between distinct functionality in our code. So it was clear that we needed to decrease the coupling between different domains, and now the question was how. One solution that is very trendy in the industry is microservices. It is an option that we explored, but one that we quickly ruled out. While microservices would address the problems we were experiencing, they'd also bring with them a whole nother suite of problems. We'd have to maintain multiple different test and deployment pipelines and take on infrastructural overhead for each service. We would also have to get creative about getting access to the data that we need because it's a lot harder for a bunch of microservices to share a database than it is for a monolith too. And since each service is deployed independently, communicating between them means making calls across the network, which adds latency with every call, decreases the overall reliability of the system, and increases vulnerability by increasing the surface area that could be attacked. Additionally, large refactors across all of the services can be really tedious, involving PRs to each service and potentially the need to coordinate deploys rather than just being able to make the change on both sides in one code base. So this is not to say that microservices are never the right solution. It just was not the right solution for us at this time, especially because transitioning from our current monolith to microservices would likely mean having to start over from scratch because of how intertwined all of our different functionality was. And we weren't super keen on scrapping about 10 years of work at this point. So where did that leave us? We wanted a solution that increased modularity without increasing the number of deployment units. This would allow us to get the advantages of both monoliths and microservices without so many of the downsides. Once it was clear that we needed to make a change, a small but mighty team of engineering leaders set out to find a solution to the problem. We wanted to be data-informed when coming up with a solution, because we wanted to ensure that we're solving the problem that we actually have, not just the anecdotally reported one. So we sent out a survey to all of our developers who were working in the core system at this time to identify the main pain points. The results of that survey informed the decision to split up our codebase. The project was initially named Break Core Up into Multiple Pieces. This is what happens when you let developers name things. But it eventually evolved into being called componentization. So componentizing our codebase is our version of implementing a modular monolith, which is a system where all the code that powers an application lives in the same codebase and is deployed to the same place, but there's strictly enforced boundaries between all of the different domains. So this all sounds like a nice idea, but what does it actually mean? How do we go about implementing it? The approach that we took can loosely be broken down into these 3 steps: reorganizing our code, isolating dependencies, and then enforcing the boundaries. Now, I'm sure this makes it sound really easy, so I'm going to just take a second here to say that it absolutely is not. I don't want to artificially get anyone's hopes up. We've been working on this for over 2 years now with a ton of very smart people, and we have made a lot of progress, but we still do have a ways to go. So let's dive into each step. The first issue we chose to address was the organization of our code. At this time, our code was organized like a typical Rails application, which is by software concepts, so models, views, and controllers. We wanted to reorganize it by real-world concepts, things like orders, shipping, inventory, and billing, in an attempt to make it easier to locate code, to locate people who understand the code, and to understand the individual pieces of the system on their own. We decided to split the code into components, where each component would be structured as its own mini Rails app. We eventually want to take this one step further and namespace each component as a Ruby module. The hope was that this new organization would highlight areas that were unnecessarily coupled, and boy did it ever. Coming up with the initial list of components was no easy task, though. It involved a lot of research and input from stakeholders in each area of the company. We did this by listing every Ruby class, which was around 6,000 in total at the time, in a massive spreadsheet, and manually labeling which component each one belonged in. And we went over this many, many, many times with stakeholders from all over the company looking at it. But once we finally completed it, we achieved the move in one big bang PR, which we built by automated scripts based off of this spreadsheet. Even though no code actually changed in this process, it still touched the entire codebase and was potentially very risky if done incorrectly. Since the changes introduced were just file moves, the failures that might occur would result from our code not knowing where to find object definitions, which would result in runtime errors. Our codebase is really well tested, so by running our tests locally and on CI without failures, as well as running through as much functionality as possible locally and on staging, we were able to ensure that nothing was missed. We chose to do it all in one PR, so we'd only disrupt developers as little as possible. There was only one day of rebase hell, rather than what could have potentially been months if we did this over time. Once we had the code organized into components, the next step was isolating dependencies by decoupling the components from one another. Each component defined a clean, dedicated interface with domain boundaries expressed through a public API, and took exclusive ownership of its associated data. The componentization team couldn't achieve this for the whole Shopify codebase. Doing so required involvement of experts from each business domain, so each dev team took responsibility to do this for the components that they owned. What the componentization team did do was provide the patterns to use, as well as the tools needed to complete the task. One tool that we rely on very heavily for our componentization efforts is Wedge, which we built in-house to track the progress of each component towards its goal of isolation. It highlights any violations of domain boundaries and data coupling across boundaries. Wedge builds up a call graph and uses it to determine which of these cross-component things are OK and which are violating. As a rule of thumb, associations and inheritance across domain boundaries are always violating, and calls are violating when another component is accessed through anything other than its publicly defined API. Wedge then computes an overall score, as well as lists the violations per component. We're able to use these scores to initiate a little bit of healthy competition, which gets our devs much more motivated to work on this technical debt. Through some clever PR, our engineering leadership has managed to make it a source of pride to have the most isolated component. And we're also able to use this tool to enforce standards, like each component has to be at least 50% progress by a certain date. We aim to eventually open source this tool once we've worked out the kinks internally, but it is quite specific to Ruby. In the long term, once each component has achieved 100% isolation, we'd like to take this one step further and enforce these boundaries programmatically. While we are still researching the approach that we would want to take, the high-level plan is to have each component only load other components that it has explicitly depended upon. This would result in runtime errors if a component tried to use code in another component that it hadn't said it depended upon. We could also trigger runtime errors or failing tests when components are accessed through anything other than their public API. A nice benefit to having the dependencies explicitly stated is that it will allow us to build up a dependency graph that we can visualize and use to figure out if we have any circular dependencies or any dependencies that may have been accidental. We've learned that it's important to use your software to enforce the ideas of how you want your software to be built. People with context might leave, and people without it will always be joining. And even the most well-intentioned people can be lazy, so just asking nicely will never be good enough. I've seen this done through everything from failing tests to bots that will come in and shame any PRs that violate the rules. How you do it is not important. It's just important that it is done in whatever way makes sense for your team and your company culture. All of this work in isolating dependencies and enforcing boundaries has made it much easier for us to extract pieces out that no longer make sense living in the core code base. Because while we're not believers in microservices, we are believers in service-oriented architecture. It also lets us swap out old components that are no longer serving our merchants for new redesigned ones much more easily. There's a really great post coming out soon on our engineering blog about how we swapped out our old tax engine for a new one quite smoothly thanks to our componentization efforts. We still have a lot of work to do to make this complete, but the progress that we've seen so far tells us that it is absolutely worthwhile work to do. Interestingly enough, we mirrored our move towards a more separated code base in how we organize our company. In 2017, we split into product and service lines with clear leadership and ownership over certain parts of the product. This was done in an attempt to minimize context needed to be effective at Shopify, and also to allow each product group to feel empowered to make the decisions that they need to move quickly. Good software architecture is a constantly evolving task, and the correct solution for your app absolutely depends on the scale that you're operating at. In my opinion, monoliths, modular monoliths, and service-oriented architecture follow along an evolutionary scale as your application increases in complexity. If your team does choose to go the microservices direction, transitioning first to a modular monolith will make this process much less painful. Each architecture will be appropriate for a different sized team or app and will be separated by periods of pain and suffering. When you do start to experience many of the pain points that we were seeing before we re-architected, that's when you know that you've outgrown your current solution and it's time to look for the next one. A well-designed system can increase the joy of developing it and be a great tool for speeding up your team's productivity. In case I haven't made it obvious, this is a topic that I love to talk about. I find it extra interesting because of my experiences on all of the different ends of the architectural spectrum. In the past couple of years at Shopify, I've worked on a bunch of different teams and projects. I worked in the core code base back when it was a massive monolith. I worked on a team that extracted a service out of core before we had started any of these componentization efforts, and I can tell you it was a lot harder than it would be today. And then I also worked on a system that was made up of 13 different microservices, which we eventually decided to rebuild as a modular monolith, and we consolidated it down to 3 components, which are each deployed to a different runtime. I also wrote a post on our engineering blog about this exact topic, but I went into a little bit more of the technical implementation details, so if that's of interest to you, please give it a read. And if you have any questions or opinions that you want to share with me, then please come find me at my office hours. Thank you so much for listening.